Good evening. It's already evening. It's still good afternoon? Okay, great. So I will go till the evening. Fine. Emil, 2008. 2008, I was in SolidCAM. I remember the 2008 World Conference. It was in a small hotel in Frankfurt. 20 people were there in the entire conference. And it was an amazing one-day conference. We have grown, like today we are 400 people here attending the conference. So it means that we have grown 20 times since the time I joined. Amazing. Right, getting back to my presentation. So we are going to talk about Pro 3D HSR and HSM. And I'm going to digress from my presentation and move slightly into a topic that probably I never touched or nobody else touched about, but we are going to do that. So what is Pro 3D HSR and Pro 3D HSM? First of all, it's a new generation toolpath engine for 3-axis toolpaths, and it combines the power of Turbo HSM and a complete control of the toolpath. So good things about Turbo HSM were taken over, put it into this engine, and a complete toolpath control was given. It gives an extremely optimized toolpath. We have tested it against HSR, we have tested it against HSM, we have tested it against Turbo HSM, and we have found that the time that it takes on the machine is much lower than all of the other two engines that we were using before. Most important, it's a 64-bit architecture. That's how the software has been designed and developed on, and it supports multiple cores. So it has a multi-core support. Now, I'm going to talk about this towards the end of my presentation on why this is so important for us. Collision-free toolpaths, that goes without saying, and it has got optimized retracts using dynamic holder collision, which we are going to see in some pictures. Multi-surface offsets, you can define groups, infinite number of groups with different offsets, and it will create the toolpath by keeping those offsets what has been specified. And 2024 SP2, SolidCAM becomes the only software in the world to support a convex tip kind of a tool, the high-feed tool. You can actually program using Pro 3D HSR and Pro 3D HSM, only constant Z, with any shape of tool. It doesn't matter what shape of tool it is, you can use the tool and you can do the programming. It's not only for verification or simulation, it's also for actual mathematical calculation. So, it also has optimized fixture definition. You can define fixture either with a model or with a curve. It defines boundaries, and in this case, it's not a 2D boundary, but it's a 3D boundary, and it precisely trims the toolpath along the surface on which the boundary has been created. Selected surface, I know this was not working very well in our older HSR and HSM, but we can now be 100% sure of how it works inside Pro 3D HSM. We have done a lot of improvements to this function and integrated this inside Pro 3D HSR and HSM. We generate a lot of arcs, so if you're using the fit arcs function, you can expect the toolpath to be at least 30 to 40% shorter than the HSR or HSM toolpaths. And it has got a nice feed rate control, which automatically drops the feed rate when it is approaching into a corner or into a very tight area. Thereby, it enhances the tool life. And finally, there are unique finishing toolpath patterns that take into account accurate, updated stock. Now, this becomes very important. This is something I learned in the last couple of months, that it can take into account extremely accurate toolpath stocks. So, first of all, why did we move away from HSR and HSM? What was the need? Back in 2016, when I took over this product, I went to machining strategist headquarters in Cheltenham, and we had a long list. Me, Gennady, and Asad, we were there in Cheltenham, and we had a very long list of our feature requests that we gave to them. If I'm not wrong, we gave them about 45 points that we wanted them to integrate. But after 1 year of giving up that list, we saw nothing coming up. And I realized that probably they're not developing this product. And we had to make a decision very quickly because competition was there, strong, and we were getting weaker every day with that solution that was not really up to the mark for what the competition was offering. So we had two roads. One, I told Emil that let's find a developer and develop a 3-axis solution by ourselves. But that would mean that it would take 6-7 years to develop something what our competition today has. So that was immediately ruled out. The other road that was there in front of us was that we take another engine. Now, not many softwares in the world offer their engine or offer their algorithms to a third-party software. And this is when in one of our TAM meetings, the technical account meetings that we have with ModuleWorks every 15 days, I asked ModuleWorks, can you help us? It was a desperate plea that I made to ModuleWorks, and they came up with a solution which they offered me 2 weeks later, and that eventually became Turbo HSM. Now, cut 2 years ahead, I got a call again from one of their engineers saying that, Amod, I have bad news. We are discontinuing our Turbo HSM. We are no longer able to manage 2 teams, one for the classic engine and one for the Turbo HSM. So we would like to merge both of these engines together, and I would like to offer you a unified engine. And that's how Pro3D HSM was born. And we had no option, so I gladly took over that option that was offered to us. But in the hindsight, I believe we did a very right decision. So that's one of the reasons why we moved on to Pro3D HSR and HSM. So what are the strategies that are available? So in roughing, we have 3 strategies. In finishing, we have constant Z, constant step over, linear, rest machining, constant step over, rest machining, pencil machining. So these are all the strategies that are available, and then the combination and horizontal machining. Now, if I ask myself, if there is a mold maker today in the world with only these strategies, can he actually complete any part? What would probably be the answer? Ask your customer, with only these strategies, can you complete any part? 99% of the times, these strategies are good enough to complete any part. Okay? What you see in HSM, those 18, 20 different strategies, you actually end up using only 4 of them. You don't really use the other strategies. Those are like for academic interest. The rest 1% can be completed by adding geodesic machining to the Pro3D HSM. So you complete the offering just by using Pro3D HSM and geodesic machining. The old guard, our famous HSR and HSM. So you can see the number of strategies that were there compared to what Pro3D HSM is offering. So out of this, actually, you end up using 4 or 5 different strategies. You don't really use everything. The other things, like I said, is more for an academic interest. So it's a 2-decade-old robust toolpath engine. Even today, if I ask some of my own engineers, they still say HSR, HSM is the best. Okay? Because that's the kind of reliability that it has got over years of development and testing. The problem, it's a 32-bit engine. That means even if you give the most powerful hardware to it, it will still end up using only 1 core and not the entire memory that is available to it. So on large paths, it really slows down the calculation. So we have a problem here. It does have basic toolpath editing capabilities, which Pro3D HSM still doesn't have. There are no multi-surface offsets. You can just take one single offset and machine the part. And there is no undercut detection. So if your part has an undercut, it will still machine a straight wall, thereby wasting a lot of time on machining areas that were really not to be machined. So it can't really detect an undercut. It has got more toolpaths patterns, and it has got a very good corner finishing toolpath. Corner peg removal is absent. Like today I was talking to Felix. He said this is not there in the HSM strategy, while in Pro 3D HSM or in HSR, you can give up to 90% of the tool diameter as a step over, thereby reducing the machining time on the machine itself. And this can be achieved by having corner pegs to remove the small triangle of material that gets formed when your step over is more than 50%. So our highlights in Pro 3D HSM. First of all, this is like I even talked in my webinar, is one of the unique strategies that we have, and that is the dynamic holder checking. On the left-hand side, you have the HSM dynamic holder checking or holder checking. On the right-hand side, you have got the Pro 3D HSM toolpath with the holder. Just visually, when you look at both these toolpaths, you can tell that the toolpath on the right-hand side is much more optimized than the toolpath on the left-hand side. You can look at the retracts, you can look at the way the linkings are happening, whereas here it's clean, the linkings are optimized, it machines one after the other and not just keeps jumping from one place to the other. So it has got enhanced safety. And then in HSR and HSM, or in HSM, whatever is remaining, I really can't do anything. I have to live with that material that is remaining. But in Pro 3D HSM, I can actually take the updated stock of the previous finished operation and put it to the next operation, and it will create the toolpath only in the areas where the previous tool did not enter or did not cut. So it can precisely find out where the material is remaining and only cut those areas, and then it complete this entire job. Now, the best part about this is that in the previous softwares, in other softwares, when you use a short tool, the next tool has to be of the same diameter and the same shape. You can't put two different tools. But in Pro 3D HSM, it will allow you to put any diameter of tool, any shape of tool as the next one, as we are not dependent on the previous operation, but the previous stock. Multi-surface offsets, also a very useful feature where you can define different offsets for different groups of surfaces, and it will leave the material accordingly. 3D boundaries. You can look at the toolpath on the left-hand side. It's an HSM toolpath where the boundaries were 2D boundaries, and it's going up on the vertical walls. That's because the projection of the boundary was on a plane, whereas on the right-hand side, it's basically the 3D boundary that was sent for calculation exactly as a 3D boundary and not as a 2D boundary. Fixture definition, again, you can see on the left-hand side, on the right-hand side, the difference precisely because fixture is taken into account when the passes are being calculated. So the linking happens in the most optimized way. Arc fitting, on the left-hand side, again, the toolpath that has got approximately 91,000 blocks. Pro 3D HSM with the same arc fit tolerance generates only 51,000 blocks. So the time it takes to machine, also on the machine, is much quicker than HSM. In 2024 SP2, we introduced this function where it could calculate what is the minimum tool length that is needed to machine a certain part. So it now outputs to the user what is the tool length that is needed out of the holder, considering the holder and the geometry, and tells the user what should be the minimum tool length that needs to be out of the holder. Feed rate control, you can now control feed rates exactly in the corners. By dropping the feed rates, thereby you can reduce the tool wear that is happening when you go with the same feed rate. Some of the other features are boundary contact point definition. You can define either tooltip or tool contact point. Boundary definition by surfaces, machining only vertical walls, preventing edge rolling, very important when you're doing a die mold function, adaptive step down, cross machining, this was there already in HSM, it's also there in Pro 3D HSM, rest finishing by stock, independent cutting method, again, you can have climb conventional for two different operations within the same operation. And then you have the toolpath overlap function, which can overlap the constant Z and linear toolpath either by a distance or by an angle. Okay, and then the automatic machining angle. So let's come to the crux of our presentation. How do we fare against our competition? Okay? Now, this is where ModuleWorks helped us a lot. In fact, this is some of the slides that I've picked up from their presentation, which they presented to us. So, 4 softwares were compared. I won't name them, but 4 of the top 4 softwares which take pride in telling everyone that they are the best in 3-axis were compared against Pro3D HSR. Now, I'm talking about roughing. Calculation time of Pro3D HSR was 500% faster than the second best, which among the top 4. So it's a big difference between the calculation times. We are way, way faster than the competition. On an average, we were 14% faster on the machine compared to the competition. 14% is a big time when you take a large die and mold part. Pro3D HSM and Pro3D HSR use a functionality called as caching, where they store all the data that was used for calculation in a temporary folder and then reuse when there is a change that the user gives for that particular toolpath. For example, I want to change the step down. To change the step down, I don't really have to calculate everything. It just adjusts the step down and instantly gives you the result. So this is what the recomputation time looks like. For example, the initial computation time was 33 seconds. If we had to change the step down, the calculation was no longer 33 seconds. It came down to 22 seconds. If the change was step over change, it was only 14 seconds. And if it was only changing the links, then it was only 6 seconds of calculation. So the caching is a very, very powerful functionality. Now, I'll also come, like I said, I'm going to touch about the multi-core and other things. We were pestering ModuleWorks, saying that Pro3D HSM is really slow. Please do something about the calculation time. And every time they used to say, no, it's fast. You send us the files. So we used to send them the files, and they used to come back with the results saying that, no, it's not taking 5 minutes. It's only taking 1 minute for calculation. And we never understood why, in spite of the reason obviously being in front of us. We somehow were ignoring or overlooking the issue. And that's when we asked them, what is the system configuration that you use? Okay? How many of you here use Intel-based systems? Can everybody raise their hand who uses Intel-based systems? Everyone, almost everybody is using an Intel-based system. How many of you use an AMD-based system? 1, 2, 3, 4, 5. You can see the majority of the people get drawn into the fact that Intel is a much better computing system. Actually, it's not. If I have to compare an 8-core AMD system with an 8-core Intel system, can you tell me how many cores are available for both of them for calculation? If you're using an AMD 8-core system, you get 8 cores for computing. It's called as a performance computing, so you get all the 8 cores for calculation. But if you're using an 8-core Intel system, you only get 4 cores. The other 4 cores are called as an efficiency cores, and they're used only for operations like saving, loading a file, rotation, all those where efficiency is needed. So you actually end up getting only 4 cores. So when you do a computation, and you calculate the same system configuration between an AMD and an Intel, an AMD system outperforms the Intel system by almost 20 to 25%. I'm talking about Ryzen 7. If you're comparing Ryzen 9 and i9, it outperforms almost by 60 to 70%. And this is something that we have seen with ModuleWorks giving us data every day and day out. So what I did not Google it, but I asked ChatGPT to give me a table on how it compares a Ryzen 7 with an i7. So this is the table where it says that when you're doing multi-core calculations, like what Pro3D HSM and Pro3D HSR do, AMD system is the most Excellent system for calculation when compared with the i7. The same thing goes with i9. When you compare an i9 with a Ryzen 9, it's much better for multitasking or multi-core calculation, whereas Intel is very good when you want to calculate it on a single core. Okay? So we are now going to do more tests and come up with the most recommended system for someone who's going to use Pro3D HSM and Pro3D HSR. And definitely, I'm sure at least right now, it's not going to be an Intel-based CPU. It's going to be a Ryzen-based CPU. So we, again, pushed ModuleWorks to send us some information because we wanted to be sure that it's going to be Ryzen and not Intel. So this is the same toolpath calculated on two systems. Although this is not a very fair comparison, I'm using a Ryzen 7 against an i9. But you can see that Ryzen 7 outperformed i9 system by almost 20%. 15 to 20% was the difference between Ryzen 7 and i9. Okay, it was not a fair comparison. So if I put Ryzen 7 and i7, the difference would have been even bigger. Okay, everything same, just the systems were different. So summary. Pro3D, first of all, generates collision-free and optimized toolpaths taking into account the holder, fixture, and everything. Multi-surface offsets provide distinct stock allowances on different surface groups and ensuring the material optimization happens on the target surfaces. Fixture definition integration by curves and by surfaces take into account all the geometries and give you optimized and safe retracts in areas where it is going to have a collision with the fixture. 3D Boundary does precise trimming of the toolpaths to ensure that there are no jumps on the vertical walls, and we use the 3D Boundary and send the boundary as a 3D boundary to the engine for calculation. Reduced NC blocks through arc fit. You can see that it was almost 40% smaller. The program size was 40% smaller than the HSM program. And fast toolpath computation. I've given you ample proof that we are very fast when it comes to calculation versus our competition. And above all, these factors actually make Pro3D HSR and Pro3D HSM a natural choice to replace HSR and HSM. I don't think, as we talk, I mean, the only thing that is missing now in Pro3D HSM is the contour rest machining. And as we talk today, ModuleWorks has already released this as a beta option for us to test this functionality in SolidCAM. So we should be starting our testing probably in a month or two from now with the new function that ModuleWorks developed it for us. In fact, it was our push for them that made it develop. So it's ready. Anybody who has any doubts about this, please remove it. In fact, today morning, I showed to Ilker one of his customers that I went and met and showed him Pro3D HSM actually moved away now from HSR and HSM. And every week, I see him putting new images of the parts that he has cut with Pro3D HSR and Pro3D HSM. It is ready. It's all here for us. Okay? So, thank you very much.